Thanks for coming. My name is Leland Richardson. I work at Airbnb. I work on React Native. I've been working on React Native for about 8 months now. And if you've used the Airbnb app, you've likely used some React Native. It's not completely built in React Native, only partly. And the learnings that we found is that there's a high cost to integrating React Native into an existing app, but the payoff is really high. So I'm going to talk to you today about what some of those learnings are, maybe help you use React Native in your app. All right. This happened about 2 years ago. ReactiveConf, React Native was announced. And that was a really exciting moment. If you're anything like me, maybe your reaction was something like this. React Native, felt sort of revolutionary. I wanted to play with it right away, and so I did, and it was really great. It was easy to get started, right? All I have to do is install the React Native CLI and npm or React Native init, start my new project, and I'm off to the races, right? It sort of starts a template, kind of like Create React App, if you've heard of that. But this actually, this works great if you're starting fresh, right? You're starting with a new app. But I can't really do this with like Airbnb's app, right? I can't like CD into Airbnb app and React Native init. That won't work. So this is just the first of kind of many things that are just not going to work out of the box for you. So for the purpose of this talk, I'm going to talk about Brownfield versus Greenfield. So a Greenfield app is kind of the React Native init approach, right? We're starting fresh. We can use whatever we want. There's no lines of code written. And it's probably going to be maybe completely in React Native if you're starting at this point like that. And a Brownfield app is like everything else, right? We're starting with an existing app. And how does that work? So we're going to talk about kind of all the things that being a Brownfield React Native app means. So for one, it means you already have a lot of existing infrastructure, right? Brownfield apps, they have things like localization frameworks already built in, data fetching, crash logging, UI patterns, navigation, lots of global app state, like maybe a current logged in user, things like that, and a lot of stuff that relies on that. And so you have to get to that somehow. There's a lot of existing code, right? Presumably you have an app at this point, so it's literally the entire app, and you're just adding React Native on top of that. So you have to work with that. And then perhaps most importantly, there may be existing native teams that actually built the app, right? And there's a high probability that these engineers maybe they don't know or even don't like JavaScript or React. There's a high probability that the engineers working on iOS have an entirely different workflow than the engineers working on Android, right? They have different meetings, different teams, different conventions, all of these things. And actually, one of the more important differences is that they probably exist in separate repositories, right? It's not typical for an app, for an iOS and an Android app to start off in sort of a monorepo structure, right? So that kind of brings us to our first really big problem, the multi-repo problem, right? So Airbnb, when we started using React Native, we had separate iOS and Android code bases. Most companies do, and so it looks something like this. And a big value proposition of React Native is that you can write code and it will be out of the box cross-platform. So where do we write our React Native code? Which repository do we choose? The kind of only obvious choice remaining is to actually create a new repository and put your React Native code there, right? So when we have 3 repositories, the first 2 were already existing. and they probably have like kind of an existing continuous integration setup, right? You've got build scripts, you've got unit tests and integration tests, all these things, and now all of a sudden we're writing application code in an entirely separate repo, and we have to figure out if we broke something, right? We have to figure out if our code actually works. And so how does this workflow like work? How do we make this be like a safe thing? The main thing here is that we're maybe only evaluating React Native at this point, right? Like maybe not everyone's sold on the idea, and so we want to try it out, and we can't get it's unreasonable to ask for us to merge the repos together just to try out a new technology. That's kind of a ridiculous proposition. So we're going down this kind of more difficult path, but some way that'll work. So when we're writing code, we put up a PR for our React Native. We change some JavaScript file. It's a small diff. We're ready to go. We want to merge it in the master. So we go ahead, merge it in the master, and at this point, we're going to start running our new repos CI script. And this is actually where it gets tricky and kind of involved. So we're going to do a couple things here in this build script. First thing we're going to do, we're going to clone the iOS and the Android repo locally on the CI server, right? We're going to put them in some temporary directory, and then we're going to build the React Native code. And if we have any sort of JavaScript unit tests or anything like that, we'll go ahead and run those, maybe some linting. And at that point, if everything looks good, we have a new sort of JavaScript bundle that we can use. And we're going to shove that into the iOS and Android repos that we cloned locally, and we're going to run all of those tests. And that's going to take a long time, but it'll be worth it, because you got to get that green build, right? And so once that build turns green, we're actually going to commit and push to master of both the iOS and Android repos. Now, you might be looking at this and saying, whoa, are we really going to do all that? It's kind of it's a scary situation, but it's sort of one of the things that I found that has the path of least friction, right? We want to make sure that we can integrate with those existing native teams and those existing code bases and start trying out React Native. And we don't need to remember to build files. We don't need to like do that when we merge our PR or anything like that. There's less chance of conflicts from multiple PRs getting merged and having the build files kind of clobber each other. And then perhaps the most important thing is it doesn't change the workflow of anyone else working on the native repos. So iOS and Android, they don't have to install npm. They don't have to run the packager when they run the app. They're running the app kind of similar to how a user would run it. It's just going to use the local build file. So those are kind of the benefits. There's a lot of issues though. So there's a big time delay between merging something in the master of the React Native repo and actually getting the build artifact into the iOS and Android repos. So that produces sort of some inconsistencies. We lose atomicity, right? So if we have a change that's maybe dependent on another change that needs to happen in the iOS or Android repo, then at that point it's kind of like a race condition. We have to figure out how to merge them together, and that can get really nasty. We also, all of the native dependencies that we're using for React Native, any third-party libraries or anything like that, we actually have to have them in 3 places now, which can be a pain with upgrading and things like that. And then our actual build files are checked into version control, and we don't really like to do that. And then also a high frequency of commits can result in a lot of big delays. And this makes cherry picking kind of a really difficult process. If you need to cherry pick something into a branch, you have to kind of do that manually because you need to actually run the build script. So that all sounds pretty close to awful. And so eventually, if you try React Native and you're convinced that it's a good way forward for your team, then you can do what we did and eventually consolidate into Monorepo. And monorepos have a lot of advantages. So we get that atomicity, right? We can make PRs and changes that affect all three code bases at the same time and have dependencies and be able to make those breaking changes without much effort. There's one source of truth for which native dependencies you're on. So we just need to install those third-party libraries once. And all of the actual React Native bundle files, those are all built at build time, which makes sense. So that just becomes part of your build pipeline, and you never have any issues with inconsistencies or merge conflicts. So I guess it's worth pointing out that one potential issue with the monorepo approach is that there's a lot of additional strain that's placed on your infrastructure at that point because you have a much larger repo, a lot more people committing to the same repo, and that's worth mentioning. But this is definitely the best way forward. So the next big problem that you might run into, especially in a brownfield app, I'll call the navigation problem. Navigation has proven to be a difficult thing for React Native. If we're going out and we're looking for what navigation library works best for us, it can be kind of daunting, right? So the React Native core itself has three sort of options here. And the recommended one is got experimental attached to the end of it. So then maybe you go and look for third-party solutions, and there's a number of them. A lot of them maybe just extend the built-in ones. A lot of them are their entire own solutions. Some of them are even forks. It's a lot to choose from. And then we end up looking at them, and actually, none of them really solve the brownfield use cases. So what are the brownfield use cases? What's different about brownfield apps? One thing is that we have native screens already existing, right? And so we need to be able to add new React Native screens and be able to navigate into them and back out. And all kinds of in between without the user knowing that anything has changed, right? We don't want React Native to look like something different. And so one example of where this breaks down when we're using JavaScript-based navigation is this example where you're navigating from a native screen on iOS to a React Native one. And the way this happens, if you look carefully, when we make the first transition, the navigation bar is actually going to get pushed off the screen, right? So we're pushing a whole new navigation bar onto the screen. But this isn't actually how the iOS nav bar works. And so the rest of our app probably doesn't look like that. And so the user will notice that something's a little bit weird. And what we expect is something a little more like this, right? Where the actual navigation bar persists across screen transitions, and things like the title and the icons and various aspects of the navigation bar just change fluidly during that transition. And that's impossible to do completely in JavaScript, right? Because in React Native, we have that React Native environment, and we can't render outside of it. And so that nav bar can't be rendered with React Native at that point. So what do we do when nothing solves our problems? We go ahead and create another one. So we built a Navigator. It's not open source, but it will be. I'm working on it. I was hoping to have it done by today's talk, but that didn't exactly happen. So I'm gonna walk through a little bit about it and why it's different and what the API might look like. The first kind of fundamental difference here is that we're treating screens as kind of the fundamental unit. React Native by default kind of exists as the whole application inside one root view. What we're changing is we have a new root view for every screen, right? And what we actually do is we attach that root view and kind of associate it with, in the case of iOS, a view controller, and in the case of Android, either an activity or a fragment. And what this does is this really aligns us with the platform. The platforms expect screens to be these fundamental units, and there's a lot of things that you're kind of going against the grain that require hacks to work around, that when you do this, just kind of fall away. So what does this look like? In JavaScript, we import the Navigator, and we have a registration mechanism similar to currently registering your app. We register a screen and have a thunk to the screen component, and there's kind of like a URL looking thing that's really just a key to identify that screen in the app. Now there's a fairly large kind of API, but the core of it is this. We're able to push and present new screens at any point, and that requires that URL or key of the screen we want to go to, and then we can pass in any number of props as the second argument that will go to that screen, and there's a third argument for options that you would rarely end up using. What's interesting is both push and present here actually return a promise. And it's a promise that resolves when the screen you pushed or presented gets dismissed or popped, right? And that ends up being useful for integration with native apps, but especially with Android. Android has a concept of starting an activity for a result. And so we're able to start a native flow in this case as well as a React Native flow and get a result back. A common example of that might be logging in to presenting a login screen to a user and then returning if they actually logged in or not. And then pop or dismiss actually just pop or dismiss the current screen. So a quick example, kind of demonstration of this in action. The navigation bar here is being rendered completely natively, and you can see that it can take both modes of transparency or solid colors, and the animations that are happening here, the easing curves of these transitions, are all using the platform to do that animation, so they will match identically to the rest of your app, and to what the user expects. An interesting property of the API that we took here is that the navigation bar is actually configurable in the render path. What that allows us to do is have the styling of the navigation bar actually configured by a component at any level of depth in the render tree. And this has some interesting properties. If you have components that render a certain type of thing where you know what the navigation bar should look like, then you can go ahead and configure it there. And then the API that's exposed to the consumer of that component, they don't need to worry about configuring the navigation bar. So the way we're able to do this configuration of the nav bar in the render path is with this special component that we've created called navigator.config. And you can render any number of these, and they will resolve with some deterministic kind of resolution, but it's a declarative component that you pass props in. These props can be a function of props and state in your component, and there's also various callbacks that are useful, like on up here. In addition to that, we also handle scrolling in a special way here. We have a way of identifying a scroll view as kind of the screen's main scroll view. And it's a typical pattern to have navigation bars kind of behave differently, or at least listen to the scroll position and change their appearance as a result. And actually, in our case, it's different for each platform. On Android, we push the nav bar off the screen, kind of like a shy nav bar approach. And in iOS, we keep it on the screen, but we can transition from transparency to being opaque. And this is kind of an example of this is a trimmed down version of what that screen would kind of look like in terms of our components here. You can see we have this scroll scene component and this editorial marquee components, which are kind of the special components here. That editorial marquee, it had been rendered in a way where it had this navigator.config set, and that configured the nav bar. And then the scroll scene is something that would accept. It's just a wrapper around a normal scroll view, but we end up passing in a context property here, which the underlying implementation then knows how to attach that scroll view to the nav bar of that screen. And that navigator config component is actually just, it doesn't render anything, at least not in the React sense. What it does is it's just a sort of state machine that handles component did mount, component will receive props, and then there's sort of this state transition function where we can tell if the props have changed, and then we end up setting the bar type for that screen or setting other properties. Another thing that we're able to do is shared element transitions. This has become a common pattern in mobile apps that is pretty difficult to do in React Native. It's possible, but what's not possible is doing shared element transitions from a native screen to a React Native screen, or vice versa. And that's what we're able to do. And I'll show you a little bit about what the API for this looks like. So in this example, we have kind of two screens, right? We have the screen that we're coming from and the screen that we're going to. And on the first screen, we have some number of these sort of special shared element components, which don't actually render anything. They just sort of annotate other views, right? And so in this case, it's wrapped around this image. And we assign it an ID of sorts, right? And so in the next screen, we expect there to be a similar shared element with the same ID. And then the library ends up kind of scanning the view hierarchies of both screens and finding the matches. Then what happens, and this is a little bit important, is we have this transition group, a shared element group, where when we're making the navigation, we actually want to specify where the navigation came from, because we might have several points or several images on the page that like could be shared elements, but we don't want those. We want the one that the user interacted with. And so when we do the navigator.push, we pass in that transition ID as an option. So what are the advantages here of this type of brownfield navigation? One, it's really, really easy to transition to and from native or React Native views, right? Native flows just get a similar URL type structure, and we can push native views just like we push React Native views, and we can easily push React Native views from native. An interesting side effect of this is that we can navigate deeply into our app and use React Native's live reload, and our navigation state isn't lost. We're actually just refreshing the JavaScript runtime, but the navigation state lives natively. So we end up just refreshing that page, and that provides like a much better developer experience. The other thing is transitions are performant by default. We're using everything entirely native here. There's no JavaScript driving this animation. So we don't have to worry about React kind of blocking the JavaScript thread while this transition is happening. And also, configuring the navigation bar in the render path, I think, is a huge win. A lot of times we want to set a title based on some props that we have, or we want to conditionally render something that might change, like the buttons that are available in the navigation bar and things like that. And having it as something that's configurable in the render path just makes for a really consistent and like understandable React Native API. And we align with the platform conventions here. There's things like the Android back button that just work by default. We don't have a single line of code in our app handling like weird back button issues with React Native. It just works. So there are maybe a couple of disadvantages that are worth mentioning. One, the navigation bar is not in React, right? It's not a React component. So it sort of assumes that you already have a navigation bar that you're using. And then also screen props are serialized and deserialized. So you pay a small serialization penalty in that case. And you can't pass functions across them. Also, navigation state is native. It lives natively. You can't really query it in your app. Hasn't really been an issue for us. It's worth pointing out that these two are actually requirements for us. We couldn't have it any other way. And it's also worth pointing out that I'm going to try and solve the first two issues before open sourcing it. I'm out of time here, but I'm gonna run through these last slides pretty quickly. Some additional challenges that we have: type safety. Native engineers kind of expect a type-safe language, and working with this can be a concern for a lot of them. Educating people about React Native that haven't used it before, there's definitely a cost there. Be prepared to write native modules. They're necessary. If you're integrating with an existing app, you're gonna need to write communication layers that handle things. Also, I found that it's hard to get people to actually develop with this cross-platform mindset. We actually want engineers to be developing with both the Android and iOS simulator running at the same time. And that's sometimes hard. So the payoff, really, we get one feature and one engineer, and we can implement it in 3 platforms. That is really, really powerful. Can't be understated. A code push is something that's incredibly valuable to us. Can get to the point where we're continuously deploying the React Native portion of our app, which is incredibly valuable and a big productivity boost. Live reload, another big productivity boost. React itself is really, really is kind of like a benefit in and of itself, right? React is something that I think at least a lot of people here are kind of bought into the UI paradigm that it brings and how that scales to large apps. We're able to share code. And just to finish up, I kind of wanted to give sort of some brief understanding of where React Native sort of stands today at Airbnb. And I ran some scripts this morning. We have 107 registered screens in the app built with React Native. That's roughly 415 React components. And all of that is built with about 71,000 lines of code of JavaScript. And that's excluding comments and blanks and stuff like that. If you compare that to the Android app, our Android app has around 271,000 lines of Java and another 200,000 lines of XML. Compared to the iOS app, we have about 300,000 lines of Swift and 164,000 lines of Objective-C. So it seems like maybe if you were trying to put it somewhere, like React Native kind of stands right now as maybe somewhere between 10 and 15% of the app. Thank you.
Awesome, thank you very much. Let's look at only 88. That means something's working, okay.
we actually talked backstage. We were wondering what the top question would be, and this is what I thought it would be. So the parts of the app, parts of the Airbnb app that are built in React Native, some of them I can't tell you about, but you may find out later in November. And there are various parts of the user flow. There's like if you alter reservation, if you post reviews, parts of the host app, things like that. But I should emphasize it's still a small part of the app, and the bulk of that code that I was talking about is still yet to be released features. What? That sounds a little bit high, but it is really, really high. I think we just got it under 100 megabytes. It's really big. One of the reasons it's really big is because of our Swift usage, and Swift had some unexpected effects on binary size. I think a lot of them are related to the usage of structs, and we're like really currently investigating that issue. When we started adopting Swift, the size of our app skyrocketed, and yeah, still under investigation. How successful has the adoption of React Native at Airbnb been? Could you share any metrics or anecdotes about productivity, etc.? Yeah, this is the productivity thing. It's like hard to measure. There's kind of like some guttural sort of feelings, but I feel like it was from an infrastructure level. It was really difficult to get React Native into a stable place, and there's still a lot of things that we're working on. From the building products level, beyond like the infrastructure side, I think we found it to be incredibly productive. We're able to write cross-platform code. We write the feature once, and it works on both iOS and Android. We've had some fairly complicated features get out the door in like a week. So we've been pretty pleased. Do you use code push? Depends what you mean by use. We don't currently use it as much as we'd like to, and a big part of that is because we need to build up confidence in our ability to code push without shipping bugs basically to production. And so currently I'm working on building out our end-to-end testing on React Native and the rest of the mobile apps so that we can do this in a way where we have confidence. Will Airbnb switch to React Native entirely over time? Still an open question. I don't. It's possible, but it's like it's really far away, right? Like you saw, we're like maybe at 10%. It's growing very quickly. I think that we're incrementally trying like more and more difficult features, and I would say that right now there's maybe almost nothing that we don't think that we could safely do in React Native in the app. But ultimately, it's our engineers' choice, and we're still kind of building up support for it and interest in training new people. What do you think about native scripts? I don't know a whole lot about it. We evaluated other technologies when we started working on React Native, but ultimately React Native was kind of the only one that made sense for us. We just have a lot of built-in React experience. We had the most sort of support for it, and just seems like the right choice.
So time for one last question.
Okay. Why not merge all repos into a single one with different folders? Well, that's what we did. I mean, that's the Monorepo. The idea was that was a big ask early on. We started off with the understanding that React Native was an experimental technology. It was something we were evaluating, and you can't really ask like to merge two of our largest like repos with many dozens of engineers working on it just to try out a new technology. And so this was the best compromise that we came up with.
And the last one, I just love it. That's something I understand as well. So, did you book your stay with Airbnb in Bratislava?
I certainly would have, but Vacuum Labs was kind enough to put me up here free of charge, and yeah, they've been really great hosts to this conference. So also thank you to them.
That wasn't a setup, but thank you. Yeah. Thanks.